welcome. My name's John Pugh. We have David Coe and Eduardo Miranda with us. This is going to be talking about what's new in Longhorn 1.2. Our agenda, we just went through the introductions. We're going to talk about what's new in Longhorn. I'm sure David has plenty of demonstrations for us. Do please ask questions in the question box. You will see that dialog box there. Ask any question you like. Let's try to keep it focused to Longhorn if we can. Eduardo is going to help us out with some of those questions as well. And as we go through the presentation, we can get those answered. We already went through the introductions. Myself, David, and Eduardo are going to be your hosts today. But first things first, let's talk a little bit about what this is. So remember, this is a meetup. We're not really doing a webinar. We're not going to be spewing to you. We are going to be interactive. We want this to be interactive with you. Ask questions, learn. This is all about you all, so make sure that you do ask questions in there on any topic, but if we can focus it on Longhorn, that'd be even better. We may run over time. We slotted 2 hours. It's really late for David, so we're going to try to keep it into about an hour if we can. Do ask questions. Remember, there isn't any bad questions. We are going to be demonstrating live most likely, so things could break. Just be patient with us, as we already did a false start already this morning, or this afternoon or this evening, wherever you may be. We are recording. We will post this to YouTube. That's usually the first question that comes up. It's not up there yet, but this is the first question we always get. Is this being recorded? And yes, it is. You see the link down there on the bottom, youtube.com/c/rancher. We'll post that as soon as we get it cleaned up after the session's over. A couple other things, do join us on Slack. If you go to slack.rancher.io, you can register and get signed up for our Slack. There is a Longhorn channel in there to talk about Longhorn. A lot of the engineers, product managers, field engineers do hang out there. So if you have questions, that's another good place to get them answered. Also, join the SUSE community. So community.suse.com, a very popular place for not only answering questions about the technology, and there are a lot of the engineers and stuff that hang out there as well. We also have a lot of events on a regular basis. And I've got some of those posted at the end, but if you go to community.suse.com/events, you'll see all the events that are running. As a matter of fact, simultaneously right now, we have up and running Rancher. That is a academy course that goes through Rancher 2.6. There's a whole bunch of detail in there for getting started and getting in-depth into Rancher 2.6.
Okay, so let's get started. So today I want to share about what's new in Longhorn 1.2. As you know, we just released Longhorn 1.2 with a few patches already. So today's meeting, I want to share more about what we really introduced in 1.2. So before that, I still want to introduce some background for Longhorn on what's a Longhorn use case or even feature set first, because I believe some people join this meetup even don't know Longhorn yet or even want to understand what's a Longhorn. So the first section I will introduce a bit. And after that, we will dive into 1.2 major feature demo. So have a 2 session. So the first, before we talk about Longhorn, and we think about what the Longhorn want to resolve the problem, because as you know, if you want to have a storage solution, storage cluster solution, you definitely have some. If you think about a previous solution, you definitely have like external storage array, and have some factors you need to consider, like location or infra constraint. And also, it's not definitely designed for Kubernetes. So we look back and think about how we can do better for Kubernetes workload and make the data around the workload and provide some hyper-converged solution based on Kubernetes. It's a total design for Kubernetes. This is what Longhorn come from. And so what's a Longhorn? Basically, a few items here I want to emphasize. The first one is highly available and software-defined persistent block storage built on Kubernetes and built for Kubernetes workload. And also it's lightweight, reliable, easy to use. That means you can run the Longhorn workload together with the Kubernetes cluster, like an in-cluster storage solution for your workload. And also, if you talk about how to manage a storage solution, from Longhorn is much easier. We have a different way for Longhorn installation. Take example, if you want to leverage Rancher, you can just have install from the Rancher app catalog to install from there, or even upgrade from there. And our configuration is based on Helm chart, but we have a customized configuration for Rancher interface. So you can get a easy pace to do some customization. And also, the most important for Longhorn is provide based on the Kubernetes persistent volume concept. So we provide the persistent volume concept for different access type, volume modes, and especially this is running for any certified Kubernetes cluster, including K3s as well. And the other one, we talk about what storage used by Longhorn. Actually, the storage agnostic. So it's based on the host file system. So the current we support ext4 and xfs file system on host. So they mean the file system can be regarded as a disk for Longhorn cluster. So you can have multiple folders with the different file system regard a different disk for Longhorn, because for Longhorn the disk is the basket unit for the replicate scheduling. And also not just volume functionality itself, we also have built-in backup resource support. So and also support the NFS and S3 backup compatible storage. And of course, like I said, the first item, Longhorn is based on Kubernetes. So all the designs, workload, even persistent stuff is on Kubernetes itself, based on the CRD and control plane. Or as you know, we can call it operator patterns to manage how to handle the volume attachment lifecycle. And last one is the most important. It's a 100% open source project, and we donate to CNCF 2 years ago as a sandbox project. And right now, good news for everyone is Longhorn is moving to incubation project, and you will be possibly be a first project in the storage area under CNCF. So this is Longhorn. And also, I want to talk about a little bit about Longhorn position in the Rancher project or product portfolio. As you know, Longhorn position in the Rancher portfolio is like a share tooling and service. So if you look at the Rancher 2.6, you will see some supported some cluster tools section in the Rancher sidebar. And this one, Longhorn is the one solution for the storage part, and also responsible for all the cluster. If you deploy on the by Rancher, you can use the Longhorn as a default storage cluster, and you can install it from the Rancher app catalog. So this is what we position in the Rancher product portfolio. And we quickly understand the Longhorn story. Actually, Longhorn not just start from the Kubernetes, it started before. So writing in the C++ in the 2014, and later along the Kubernetes journey, we try to make sure we align with some terminology and concept introduced by Kubernetes, like a persistent volume and CSI. So you will see the different minor release, like 0.3, we start have like a data service around the volume management, like a backup restore. And 0.6, we try to introduce a disaster recovery volume support, and also create the standard installation way for the Kubernetes application, like Helm chart, and also donate to CNCF. And from 1.0, we start to align with the CSI spec, have volume resizing and also take care about the resilience area. So like an automatic recovery for faulted or volume with no down or no up have a corresponding behavior. And also air gap, and this is the first GA version. So we want to target not just open source project only, we also look for the enterprise user Longhorn from 1 level. And after 1.0, we have a 1.1 and 1.2, and start to expand the Longhorn support in the different architecture and platform, or even volume access mode. Like 1.1, we have an experimental feature for rewrite many, and also ARM64 support. And around the Longhorn cluster, we also provide a different metrics and built-in dashboard you can integrate into your Grafana based on permission metrics. And right now, 1.2 is arriving. We just released, and several enhancement and improvement and introduced. And like here, I can say we have the encryption finally introduced for the volume encryption and corresponding backup encryption. And also, and actually based on Longhorn design, I will talk about later Longhorn architecture. So encryption can be happen at rest and in transit. And also, as you know, Longhorn have a recurring job. And in 1.2, we try to move all the configuration to see the customer resource base to make this is the unified interface for user. So and recurring job in the previous version, actually you can what you can say is that in a storage class or even update in the volume CR. But right now, recurring job can be shareable and reusable, and even introduce group concept. So it's a better leverage the new recurring job to manage your backup and snapshot. So this is current 1.2, and this is a brief Longhorn story. And where is Longhorn right now? Longhorn is getting popular and mature, but still we still have a lot of things to do. But right now you will see after CNCF donation, after 2 years, we got a 50 times growth. And actually in the world, we have certified 1,000 nodes actively running Longhorn. So this is the great opportunity for us and great growth for us. And the other exciting things, the Longhorn is not just used by the open source project or community user only. You also used by adopt by enterprise user. This I want to highlight. So they mean the Longhorn is ready for production, not just dev and test. And also we support a different area like edge. So this is Longhorn patient. But we just not stop here. We look further to like right now 1.2 we support virtual orchestration support like a virtual machine, the storage backend for virtual machine. This is another area I want to extend a bit for Longhorn beyond the traditional volume management or storage management. So this diagram is just show this is real data to see the steady increase in growth active nodes running over the past 2 years. And we simply talk about what's a Longhorn, and let's look at in general what Longhorn use case mostly. So this is a list. We have a lot of lists. But this list is most highlight the major items people use. So like the first one, we have an enterprise grade distributed block storage. So it's just a block storage based on the volume to provide different access mode, like a rewrite many and rewrite only. And also we have a market leading performance. We try to do some performance testing in each release, even in 1.2, and we will come out a performance report based on 1.2 in near future. So, and we get some improved actually. So you can expand the report in the future. And also around the volume functionality, we based on simple provision. So you can over provision your volume allocatable size, volume size, And also routing around the snapshot, we have an incremental snapshot and to fulfill the like copy and write behavior. And also routing have a backup and restore. This is built-in function. You don't need to install any third-party solution. Don't already have that. So you can you can do something based on backup and restore, like a disaster recovery, and also routing expansion, resize. And except the routing, besides the routing functionality, we also think about how to make the Longhorn can be scalable and stable and resilient in a different area. So across the different node available node for the replica scheduling is very important for us. So we designed Longhorn have a built-in the replica scheduling depend on different configuration control plane feature set like software node anti-affinity or even software zone anti-affinity to understand how to arrange the replica in available disk and storage in different nodes. So this is the most important part. So you will see the replica rebuilding in some situation. And the other one, the right side, we have a storage tag for node and disk section because we know people probably would want to have some node have specific usage or some disk in the node is specific usage. So when you create volume, you can use a storage tag to select which node or even which disk you want to have the data or replica locate on it. And like I say, because Longhorn have a built-in backup restore, so cross the disaster recovery can based on that. So you can have your defined a recovery target object RTO and RPO to have a better to recover your data in a standby cluster. And that's why rewrite many, because we heard a lot from the users, they need rewrite many to support. So Longhorn actually has that. So that means that you have different workload can use the same volume based on rewrite many. But actually, we encourage people use the rewrite only because in the modern application, it based on rewrite only, and you can on top of that application level have a distributed application based on that to do so more modern behavior like a replication on top of that. So, but we do support a rewrite many, but it's an experimental feature yet. And also we think about from the operation point of view, we want to support live upgrade for your Longhorn installation, your Longhorn cluster without impacting the running volume. So like a live a Longhorn engine upgrade or have some behavior to engine image upgrade. So this kind of behavior actually introduced in the Longhorn already. And next one is recurring job, like I say, because we have a built-in backup restore. So we think about people, we have a schedulable backup for that, even schedulable snapshot in cluster. So recurring job is one major feature used by the user. And the last one, intuitive UI. Longhorn UI is not like quite fancy, but it's a touch point. So it let you easy to use and create volume from the UI, or even you can create a PV and PVC based on the created volume, or even do more. Most of our operation you can do from the UI. So this is the major feature list I want to share here, but I encourage you take a look along documentation. We have a very detailed and rich documentation there. So you can look around for the complete feature set, a special setting page, because setting page have a lot of settings around the Longhorn control plane can support. Okay, performance is like I say, we have incoming reports for 1.2, and we try to compare with the different solution in the market. Depends on different factors. So I would say in the coming report, based on remote replicated, we have better IOPS, even random read, random write, or sequential read, or sequential write. And also latency, if you compare with other solutions, we also have a good performance compared with others. But again, this kind of testing is based on the different factors like networking, network latency between nodes, and CPU, enough CPU for long workload, this kind of thing. But for the detail, we will share in the future. And this is some use case example. Like this one is like if you have a multiple zone, and if you in a traditional workload and your volume is in each node, you even cannot move the workload around, leave from the nodes. But in Longhorn, we can do that because of replication and Longhorn architecture. Because Longhorn architecture engine is as a front end for the volume, it can move around along with your workload, but replication can actually in the different nodes. So this is how we fulfill the part keep running even data is not in the same node or even in the same zone. And the other side for Longhorn, because like I say, Longhorn is a storage is based on the disk concept, and disk concept is based on the host file system. So they mean that you can define your mount point, the file system as a Longhorn disk, and actually use the like a volume group to include a different storage backend together to fulfill this disk, a Longhorn disk. So this is what the different things we have done in Longhorn compared with other solutions. And this one is disaster recovery. It's the result on the backup restore. And think about it. You have an active cluster and standby cluster. Active cluster A, standby cluster B. And you can make a scheduled backup, continue send the delta of the backup of volume to the external backup storage, S3 compatible NFS. And standby disaster recovery volume, you will passively gather delta of a volume data backed. So when your cluster A get some troubles, you can get the standby cluster to activate the standby disaster recovery volume active to start to serve your continue serving your service. So this is another scenario introduced by Longhorn, and this is actually a built-in functionality. So this is what I say, different zones, if you just use a traditional block storage, you even cannot move around. If your part move on different zone, you cannot access, right? But in Longhorn, we have our architecture. And back to say, we have volume, the Longhorn engine, and also the data is set in a Longhorn replica. So when your part in running in different nodes, take example like node 2, and you will request the volume layer, and Longhorn engine will be create there, but Longhorn replica maybe is not in the same zone. So they mean you can move around your workload, depends on your node status, but your data will try to connect. If your replica on the node have some trouble, you can get rebuilt correctly you can still access your volume in different nodes. So this is what we achieved, like I explained before in previous slide. And next one is a Longhorn architecture. So we talk about what's a Longhorn and Longhorn more usual common use case. And let's talk about the Longhorn architecture. So Longhorn architecture actually have two major parts. One is engine, and the other one is replica. If you don't know Longhorn before, the engine, you can simply say it's a front end of a data. So you can have a different mode, like bar device, or you can have a ASCII target directly. So, but here we think about if you have a workload here, and you want to launch the pod, and actually you have a PVC clamped and reference in the pod. And all the workflow life cycle, volume life cycle actually works through the Kubernetes and kubelet on the node the pod planning to running on. So, and Longhorn get understand what the PVC request. So we try to find out the available disk slot for this workload. And by default, the Longhorn is disable his configuration code software no anti-affinity. So they mean the replica cannot be recreated in the same node. You need to balance. So you will see if this volume and the storage class defined each volume should have 2 replicas in this case. So the replica will be creating node 1 and node 2 in available and suitable disk. And later, if replica is get ready and ready for read and write, an engine, Longhorn engine will be get created along with the pod. So it will be landing in the same node the pod is planning to run it on, and start connect with the replica, its replica, and later initialize the interface to that pod can mount the volume. And here we show the iSCSI interface. We have our own the TGT, the iSCSI target to create to that this block device can be mounted on the node, and data can be mounted into the pod. So this is the basic workflow along with the kubelet lifecycle, and I will talk about detail on how it actually communicate with the Longhorn. In part 2, if you have a part 2, the same, you just do the same thing to request it, and you will see here actually there are independent paths. So this is what you see. We claim that we have some like a microservice stuff and patterns, but actually what he means is like isolated segregation for the old the component, Longhorn component running for each volume to make sure the volume can be individually does not be impacted by all the volume has some problem. Okay, and the most important part, the engine and replica I mentioned here is actually orchestrated by Kubernetes. We don't have our built-in database in Longhorn control plane. We just leverage, like I say, customer resource. So all the data is actually saved in the Kubernetes API server, or we can see XCD cluster. And we know the engine and replica pairs, but what's actually inside in the Longhorn component? If you try to deploy a Longhorn, you will see in the different nodes, if there are some request layer, there will be an engine instance manager and replica instance manager there. Every node have one corresponding instance manager for engine and replica. And the purpose is we try to manage the engine for each volume in engine instance manager. Vice versa for replica, the same. Each replica is managed in replica instance manager. So here, the volume request and replica will get allocate. You have an owner and managed by one replica instance manager. If you have 2, definitely have a 2 replica instance manager. If the software node anti-affinity is disabled, and later the engine will be created in the corresponding node. The pod will running out and managed by the corresponding engine instance manager, and later we will get exposed to let the volume can be accessed in the pod. The same in other place. So the point here, the engine and replica, the life cycle. We talk about the volume life cycle, right? But engine and replica actually has its life cycle. It's measured by Longhorn component instance manager. So this is a major point. Okay. So where is the control plane? So where is the control plane? Actually, if you would look at the Kubernetes, the path for the volume lifecycle, you will see the Kubernetes, actually kubelet will try to, if you get a request, try to make the volume publish or even no publish. Control plane create a volume or provision the volume or attach a volume or mount the volume. So you will go through the CSI, the interface. So in each node, Longhorn has a CSI node plugin. So when the kubelet, each node kubelet, you will communicate with the CSI node plugin directly. And CSI node plugin will be communicate. Sorry, I have, yep, I turned off a webcam first. Seems like I have a slow networking. So can everybody hear me correctly? I think yes.
I hear you correctly.
Yeah, great. So, yeah, great. So let me continue. So Longhorn CSI plugin actually will be communicate with the Longhorn manager. Longhorn manager is actually the core of Longhorn, is the Longhorn control plane. And Longhorn manager will try to coordinate set all the data actually is based on customer resource in the Kubernetes API server. And later, you will coordinate engine and replica creation. Like I say in the previous page, the engine and replica lifecycle are managed by instance manager. So you will connect this part to communicate with the instance manager to create or even manage your engine and replica, and also monitor engine and replica status. The same for the all volume. So in each tree, subtree is actually for each volume. So it's the independence. So if you get one engine have some problems, actually you will not impact the other engine. So it's actually is the way Longhorn manage the volume lifecycle. And also not just CSI interface, you can operate through the Longhorn UI. And maybe you will have a question, can I operate the Longhorn customer resource directly? And I think yes or no. But what I say no, because we have a plan in the coming feature release. We want to make Longhorn better and want to introduce the more solid interface based on the customer resource, like introduce validation to make sure the customer resource when user operate can get a correct feedback or error message or some suggestion. So this is what we plan to do in the future. This is the end goal. We want to all the operation around the customer resource, even user interface. Okay, so we talk about the engine and replica. This is about the volume. So around let's look into the data. So the data, how it look like. Actually, the data have some concept like a volume hat. If you use empty data, like data in each replica, and you get some data inside. And if you want to have a snapshot create or even the replica rebuilding, you will try to create the snapshot. To map a snapshot is immutable, and later the volume hat is become clean. So you can keep writing to operate in the volume hat, but snapshot will be not able to modify anymore. But if you have some data is actually you need to modify in the same bucket, it will be copy and write and start the other one in the volume hat. And again, if you want to snapshot for some reason, a replica rebuilding or periodical recurring job to pick up snapshot, you will base on the bucket as well. And at the end, you will see the whole volume content is actually combine the snapshot plus the volume hat. You will see all the information. So what actually Longhorn doing is we based on Nina space file. And so we also record, update the re-index so we can understand what data in which bucket we need to access. And always write into a volume hat and update the re-index only. So this is what we manage the data in each replica, or we can say volume, and we based on the snapshot concept. And backup, the same concept, we based on the snapshot, but it's like you can call it like a delta. So in this diagram, we have a few 3 snapshots here, and we have live data or volume head. And so if you back up your data and you actually back up from snapshot 2, and you will see the data bucket will be from the snapshot 2 and 1. And if you see we have a backup from the snapshot 3, you will have backup snapshot 3, 2, 1. And actually you alone will not duplicate the delta. You just use the reference count to point to understand what exact data, the same delta they can use. So when we reference count is come to 0, the bucket will be deleted automatically. So this is the concept we leverage in the backup. So you will not have create some redundant data or delta in the backup store. And this is also the very important concept in the Longhorn replica rebuilding, because sometimes your replica will come into the unhealthy state. So replica should be go into the review or some to make it work. So how actually this done in the Longhorn? And the first, we will try to post the engine, and data we will take snapshot for the Ethereum replica. And as I say, the replica volume data is actually based on snapshot, and live data will not have a duplicate data from the snapshot. So the snapshot is very fast. And later, we will create another replica, but replica is only write only. So they mean we can unpost the engine, because the data can keep writing, and at the same time we can sync up the immutable snapshot to the new replica without impacting the new the volume the operation. And later the snapshot get copied, and we will make the replica become the rewrite. So they mean that you can read from the replica, this new replica as well, not just write. So this is basically the concept for the replica rebuilding. And how about the live upgrade? Like I say, we try to think about from the operation point of view. If you have a new Longhorn introduced, how it will be? Does it impact your volume? So right now we introduce the live upgrade. So they mean when you have a new Longhorn upgrade to a new Longhorn, and you will get, so the line is quite incorrect here, but actually line is from a front end to engine, and so the direction is incorrect here. But I will try to explain. So, yep. So on the engine, the replica your new replica based on the new Longhorn version will be created, but actually point to the same data. And later the engine will be created as well. So when you get a time to that the engine, like your workload get restart, at that time the engine will be on, and you will point your volume will mounting to the new volume front end created by a new engine. So this is basically the flow for the live upgrade. So like I said, it gets switched to the new engine, because new engine replica is got ready with the new Longhorn version. So the old engine and replica will be duplicated and deleted from the old instance manager. So you will see the instance manager with a different version. The main purpose is for the live upgrade, to make sure your volume can get upgraded without any interruption. Okay, great. So so I think I will jump into what's new in 1.2, or want to check the question first, John?
We can take some questions if you like, real quick. There were a handful of them that have come in.
Yeah.
First one is it possible to set up 2 different mount points for Longhorn data and for snapshots?
Yeah, so this I say, Yeah, because Longhorn is based on the node and based on disk. So all the replicas and volume stuff is in each disk. So you definitely can do that and have a multiple disk and let add your Longhorn node. So you'll be recognized. And also, if you want to specify which node or which disk for the volume, you can even do that to specify the storage tag.
Awesome. Another one is, it's a pretty long question, but I think the actual gist of it is he's having some issues when a pod moves to a different node. And so the question is, in case a pod must change nodes, can Longhorn automatically unmount from the previous node and mount to a new node when a stateful set pod
Yes.
using
Yeah.
PVC? Okay. Short
Yeah.
answer?
Yeah. I think it is more about the rescience or I would not say failover, but it's like how to do the migration. So I think Longhorn, yes, from the architecture you see we have a engine point of view, and engine and replica. Engine is a front end for the volume. So actually your data is in the replica. So when you get around to different nodes, actually you will be launch the new engine to connect it to the original replica if your replica is okay, or even your replica, one of replica gets something wrong. If you have at least one healthy replica, you will get rebuilt. So it still can connect with the degrade volume. So operation can be continued. So this, I hope I answered your question.
I think so. There was a question about, are there plans to implement erasure coding to provide better usable raw storage ratio?
Yeah, and we heard a few feedback from this one, but right now we don't have plan. But actually, we have the idea and actually some proof of concept is working out. Not erasure coding, but it's more like next generation Longhorn, but it's still under planning. But we will consider the different factors for the performance point of view. Yeah.
A couple more. Are there plans to add an API to allow snapshots to be coordinated to running apps to provide application consistency?
Yes. Okay. Great question. For the application, for application consistency, actually we have a plan for that. I would not say that we have an exact design idea right now, but we have a plan for that because application is for the current modern application is more like a multiple workload together. So the volume is like a group. So we have planned to do something for that because right now the Longhorn, the snapshot or even backup is actually is a volume base. So want to look forward to based on like application base, or even we can say volume group base to achieve this goal. But we have a plan in coming features.
Ah, cool. Okay. Last one for now. Can you manage ice storage like disks on a node?
Sorry, can you repeat again? Oh, iSCSI.
Yeah, I guess
Yeah,
he's. I mean, I think he's just asking if you can manage iSCSI storage the same as you would disk on a node.
yeah. Correct. For Longhorn, we have a front end. For Spark device, we also have an iSCSI target. So you can export from there if you want to use Longhorn as a iSCSI the storage service natively. You can do that. But if you talk about the iSCSI as the storage backend, as a Longhorn disk on the node, I would say yes, but it depends on the performance. So you better need to understand all the factors impact the iSCSI storage you have on the node.
Cool. All right. And Harold, if that doesn't answer your question, please clarify, and we'll get clarification on it. Well, that's it for now. You
Yeah.
want to talk about what's new in 1.2?
Yeah, sounds good. Let me. Okay, let me continue this page. Okay, sorry, let me minimize this. Okay, finally, what's new in 1.2? If you check the 1.2 release now, you probably will see a lot of items we got implement and also improve some bug fixing, performance engine stability issues. But we have a short time here, so I want to claim some feature, highlight some items we introduced in 1.2. And the first one is volume cloning. So we based on the persistent volume claimed, the concept all goes through the like a data source to make the volume cloning happening in Longhorn. So that means you can have a original volume and you can create a new volume, but based on the original volume. And you will get to try to copy a replica to create based on the replica for the new volume. So this is the volume cloning, and I will have a demo of that later. And also we enhance a bit for the backing image management for virtual machine volume support. What's that actually? Backing image is the most of terminology or term for the virtual machine. So it's like a RAW or QCAL2 this file format. And as you know, Longhorn is try to cross the line, not just traditional volume management. We want to expand our integration point for different solutions. Take example, like a harvester is the virtual machine orchestration solution based on Kubernetes, but also the storage is based on Longhorn. And we try to have a built-in solution to support this kind of VM orchestration solution. So that means you can manage your backing image file directly on the Longhorn and like create, upload, or download from remote, or even you can create backing image from volume. So this is all that naturally happened in Longhorn without any third-party integration. So it's better we can extend the integration point to other solutions. And next one, encryption. So encryption here, actually, we introduce encryption in the 1.2 and try to leverage the Linux, the kernel module, LUKS, to make sure we can to support the volume encryption. But actually, something in the background, we do some improvement, or I would not say improvement, some change in the CSI plugin, the implementation. We introduced the no stage volume phase to that the phase correctly do the mount point with the encryption part. So this is what we have done later. And in the no published volume, we do it actually by month. So this is also the benefit improvement we introduced together with this feature. And the other one is actually most asked from the community, like automatic replica rebalance. Because right now, if the replica get rebalanced, like you have a no down or no up, no down, your replica on the down node will move to the available node, right? But after the down node come back, the replica will not rebalance before the 1.2. But from 1.2, we introduced this feature. You can automatically replica rebalance based on the software node and zone anti-affinity setting. And also here for different modes here, like a best effort or less effort, and different options you can choose. And the other important part is asynchronous backup operation. Before 1.2, I probably think some of you guys probably hit some problems like latency between the Longhorn cluster or your Kubernetes cluster with a remote backup storage. And this kind of latency will cause some problem, like you doing the restoring and or even you want to operate the backup, volume backup. And right now in 1.2, the thing is changed. We introduced a synchronized way for the backup operation. All the things is asynchronized. So that means that if you have a backup remote, you will asynchronize update, you will get a list, but not just list the backup items at runtime. At runtime. Because before 1.2, when you want to list the backup, you will just like a on-demand request. But right now it's all asynchronized and set in customer resource. And we also introduced some CR like backup target, backup volume, or backup. Why we want to do that? Because like I said before, we want to have a standardized interface for user, and the standardized interface for user is actually Kubernetes customer resource. And in the previous implementation, we have several items actually don't have a customer resource. Backup is one example. Snapshot is another example. But in 1.2, backup get changed. Everything is based on customer resource. And the next one is a recurring job and group. And we already have a recurring job and group in previous version. But the thing is different. You need to define some setting in the storage cluster, or even you can update the Longhorn volume customer resource, and you cannot share it. So in 1.2, we introduced the concept recurring job customer resource and also recurring job group. So that means you can create a recurring job and assign to the volume, and the volume can be when the recurring job running, and you will understand which volume need to run the recurring job and running at one time. Or even we have a different concurrency mode. And also you can add the recurring job to a specific group and map the group assigned to the volume. So that means the volume can be assigned have multiple recurring job in one group. So this kind of flexibility to that user to better management the recurring job and using recurring job or even group. And last one is the low performance environment support for Longhorn database. If you see the several the discussion, you probably see some discussion before in the Longhorn GitHub repo is talking about the spin disk support, HDD, this kind of slow disk stuff. And in 1.2, we try to resolve this one. And the database, if a replica running on the slow disk, we try to resolve by some timeout mechanism between the engine and replica. Make sure the timeout meaningful and not just hard limit the timeout. In the previous setting is at seconds, but right now we just make sure if just the slow latency, we will keep alive to make sure the operation between the engine and replica keep going. So this is the low performance environment support for Longhorn data print. So that means if you are running on your nodes running with a spin disk, try 1.2 to see is the thing is getting improved or not. Okay, so this is the 1.2 items, and now I will go into some demos to let you guys know the functionality. Okay, can you see my screen? See my browser? I think yes.
And yes, sir.
Yes, thank you. So this is actually the recent release Venture 2.6.1. And most of people will, in the past, will ask, Longhorn get release, where is Longhorn in the Venture release? And this time we get a thing improved. We released together with the recent release 2.6.1. So in the current, you will see the marketplace, the Longhorn has the latest version, actually, 1.22. So you can try to install it and try and play. So this is one thing I want to share. So firstly, I want to share about the volume cloning. And I have prepared two demo classes here. One is for the general demo. The other one is for the encryption. So for this one, I will see it should be this one, and we have no volume here. And I want to create the volume with a workload, and workload try to write something in the volume data. And data, I want to clone. Then the volume is get ready. I want to clone the volume data from this volume, and to get the new volume up, and the data will be the same. So this is volume cloning. Okay. So I have a script here, and I want to let you guys see first. Okay, this is the source resource. Actually, just have a PVC, and we have a request, a very small size for the demo purpose, and we get wanted, and we will write data to the test file. So it's very simple. Okay, and I want to make sure what I operate is the same class, because I have two classes. Okay. Yeah, you will see the volume get created, and we will see where is the pot. Oh, it's a job. Yep, actually a job. So actually, just the operate, and the job will try to add something in the volume. So assume the volume is ready. So later, what I want to share is here. We have a clone resource here. And actually, the clone, we use the precision volume claim, and we specify the source, data source, and data source actually from the source volume. Okay, and later we will get mounted here. Yep. So it's got pendings. We will see how it works. It will take some time. So actually, if you will get the start to copy the replicate and to mount it to the new workload. Yep. You will see you try to detach, copy after, attach, copy, and detach, and then running that for the workload. Okay, you see, get ready, and our part is getting created. So let's wait a moment. So basically cloning, volume cloning is try to create new volumes and attach in the maintenance mode, try to copy the replica from the source volume. And if replica get ready, you will detach and remove from the maintenance mode. And later, you will try to go through the traditional volume lifecycle. And here, you will see the data should be in this mount point. Yep. Yeah, probably something wrong here on the volume clone. Yeah, perceive volume source and the source volume and try to get the data to data mounted, and the PVC is PV source. Okay, let's try again.
This is the beauty of live demonstrations where we can actually go through and deconstruct exactly what's going on and fix it on the fly.
Yeah, exactly. So let's try do again for this one to see the data is actually it should be ready to the mount point. Yeah, wait a second. I think before that we can do something first. Yeah, for the backing image enhancement, let's do backing image enhancement first and go back to the volume cloning data. So backing image enhancement, like I say, we introduced the integrity check. So that means you can create a backing the volumes with the integrity check. So take example like this one. Let me try to delete first. And we have some like back image on download. And actually I prefer pass here. And you can give the checksum. It's a short checksum. So later you can get the download. And you will get information here. It's in progress. And also at the same time, everything if you want to troubleshoot, you can try to look at the Longhorn control plane log. So everything will be there. So you see, you try to create a backing image download and try to request the data. And after that, you have created a backing image data source. The data source actually here, backing image data also have a different purpose. It can be is agnostic workload for backing image operation, like download or upgrade, or even copy from the body. So this is the one thing for the backing image data source. And here you try to clean up and get ready. So this is one thing, and also he will check the checksum is correct. But how about if the checksum is incorrect? Take example like this one, and we have a round checksum. And you see start to create a backing image data source pod again, and create a backing image data source pod, and start monitoring the backing image operation. For this case, it's download. So you try to operate monitoring a bit, and after monitoring, you will clean up the backing image data source. So you try to clean up, right? So the result is actually should be there. It's a fail because the checksum is incorrect. It's a match. So this is the one thing we introduce in the backing image download, and also we have a backing image upload as well. You just need to create a different part here, and also even we have export from the Longhorn body. So this is another one, and yep, great. So let me go back this one. I try to create. I think right now we don't have. We don't have a PVC or PV. Okay. Let me try to apply this one again. And yeah, we have that one pondit. Yep, the job is the job ideally should write the data to the binding. Okay, he's complete. And I want to make sure the data is really correct. So I have workload. I can quickly check what's going on here. The binding should be source. Yeah, source. Okay, let me check the data inside. Okay, wait a second. Let's see the check binding part is running up. Okay, so yep, the data is there. Okay. Let me delete this one first. And then I will run the cron job again to leverage the data source to see the data is there.
I had a quick question while we're waiting for that to finish deleting. The
Sure.
store that the new feature in 1.2, is that something that can be used for something like Harvester?
Yeah, actually, it's like I said, backing image. So the backing image is the functionality for the backing image management. So it's actually this is what we say we extend the Longhorn integration point. The one-off case is Harvester. So when you operate the Harvester, you will see you can upload the image and you can create a volume VM for the image. It's actually based on Longhorn.
Okay, cool.
Yeah, great. So okay, let's continue. I need to double check this one. Okay, it's one clone source from source and the data. Correct. Okay. Yeah. Okay, and let's see. Yeah, clone should be pending, and we will see. Let's try to see something from the. Yeah, you have some clone snapshot, right? From the which path to which path. So you will see some information here. Okay. Okay, it's probably ready, and let's see here. It's detached. So later it should be tried to. Okay, it's running. Okay, go. Okay, let's see. Yep, here we are. So the data is actually cloned from the source body. Okay, great. So the next I want to share is about the replica rebalancing. We still use this one, and I try to do something here. And let me create one volume first. Oh, before that, I want to talk about the settings. Yeah, you see the replica rebuildings that by default here is a disable. So disable means if you get your node on schedule or evict, so your replica you move into available node, and after you enable, you will not get back. You will stay there. It's current behavior. So what you need to do is you need to have a least effort or best effort, and this effort means you will try to move at least one replica to the new up node. But best effort you will try to balance it. So if you have, take example, 5 replicas, and you only have 2 nodes, and you allow the nodes of anti-affinity. So if one node down, you have only one node, right? The only one node will have a 5 replica there. But after the other node up, and the 2 of replica will move to the new up node. So you have like a 2, 3. You will try to balance that. Is that like a best effort? So let's try to have a best effort. Okay, and we create one replica. Again, not to be visible demo purpose. And let's have a 4 replicas for demo purpose. And I try to attach one node to see how it look like. Yeah, you see, right now the current balance is very good. It's a 2-2 because based on the Longhorn replica we get scheduling. If it is available node, available a disk, you will try to balance that, right? So, but we try to disable this one. Let's disable the node scheduling, and we evict it. So let the replica evict and rebuild in the other nodes. And let's go back. Yeah, you will see the scene change. The new rebuilding is getting up, and the down nodes, the replica on the down node will get deactive, right? So you see the old replica in the same node right now, and because we enable the auto rebalancing, so if right now we get it back, the scene will change again. Just take some time. Yep, something different. You try to get up on the new up node. Yep, the other one is getting rebalanced. Yep, correct. Okay, so this is the auto rebalance. So this actually getting a lot of help. It's not just a node base, it also supports a zone base. So if you you have multiple zones, so you can across the different nodes to get this rebalance. So you not just you have unbalanced nodes, have unbalanced workload data replicas on your Longhorn nodes. Okay, so this is for this one, and recurring job. Yep, let's talk about recurring job. And recurring job is quite different, and we introduced new UI as well. And here you can create a recurring job by different type, and have a concurrency. Because previous recurring job, you will run, if you have a recurring job defined in the storage cluster, it get populated to each volume, and each volume will have independent recurring job. So you will run if you have a 5 volume, have a 5 same setting recurring job, you will run 5 recurring job, cron job actually. But in the current implementation, something changed. We actually will, if your recurring job is the same one for the 5 volume, it actually just run one recurring job, but have a concurrent the process running in the cron job. So this is something different. So you can define a different number of concurrency to make sure if you have 10 volume, but you only want to run 5 volume first, and the other 5 volume is another stage. So you can set a 5. And also retention, retent. How many backup you want to retain, or how many snapshot you want to retain, you can define here. So take example, you can create a recurring job here and every minute, and we can have a backup. And like I say, we have a group concept, so you can define your group like a test group. or add to the default group. So the default group means that every volumes you get create, you'll be assigned to default group. So if your default group is empty, there's no recurring job there. But if your group default group have a recurring job, you will get automatic assign the recurring job to the new created volume. So you can create, okay, and also you can create snapshot and SAM. Okay, so it's different. And later, if you just choose one. In each volume, because it's a volume based, so you can create into the volume and you can add the recurring job here. You create new one from here or add the existing one. So take example like this one. And also you can add the group as well. Because default is the default, right? So you will get trigger. So the only one you can add is the new test. Okay. And for every backup, it actually will be run by backup controller, like this one. So if you have a backup controller, in the previous, if you do any backup or restore, there's no events, no information. But right now, we have events, so you can understand what's going on there. And you will see the recurring job happening. Yeah, you see, it actually happens. It's got 1 minute ago. It tried to create a backup, and the backup here, and this is what I want to mention as well. It's quite different. It's asynchronous, so there's actually no latencies. If you have many volume, it's very similar to the few volumes, few backups. In the previous, if you are functional backup in the remote backup target, you probably cannot load completely in this page. But right now, it's quite easy because everything is actually customer resource. So if you look at the customer resource point of view, you will see the new information here, like a backup target is a save the backup target configuration from the setting page, and also backup volume, what volume you want to backup, and also backup itself. So right now you have 3 backups, and every backup have its information from the remote backup store. So this is what I say is different than before, and we try to make the customer resource as a de facto interface for the user. And we are not complete yet. We still have a few items need to do. So please expect 1.3. We want to make the complete the interface based on customer resource as a standard API interface. Okay, so I think this is for recurring job. So I think that's it. Maybe leave some time for a question. Okay.
There's a couple more questions in here before we jump into the last portion. So one of the questions is, how exactly does Longhorn delete backups? The docs say that Longhorn periodically starts garbage collection, but how does large disks? I guess he's having. It says it works fine with smaller disks, but it does not happen with larger disks.
Yeah, understand. So I introduced the Longhorn backup behavior in the slide. Actually, it's based on delta of the blocks data. So the simply say is based on reference count. So we understand the reference count for each bucket delta. So when the delta reference count is come to 0, we know the data is actually not reference, and the data is quite small. So it's better for Longhorn to management the data and make sure that the data can better usage because it's like a small delta. Yeah.
Okay. And then the last one here, there was a question about read-write support. Let me start my Windows, we can throw that out there. Read write support. Sometimes we are facing some troubleshooting with a mismatch at ID mapd, and consequently, you must modify idmapd.conf on each host in order to avoid to run the pod with root privileges.
Root privilege. You mean, I think probably about the permission. And we have one issue in 1.2.0 is about introduce the new CSI provisioner. It get have some default option removed. So probably some of you guys encounter some performance issue, not performance, permission issue. And you need to, if you have a not non-root the permission, you get have the incorrect the volume permission inside the pod. And this one actually got fixed in the latest patch release 1.2. So please go try.
Okay, cool. Now, one final question. This is a simple one. How do you enable dark mode in the Longhorn UI?
Actually, it's a Chrome. It's my browser plugin. So it's not a Longhorn itself. But I have a good news for you guys. Longhorn we plan to have a new UI revolution and refactoring. So different modes is considered as well, like the Venture UI as well.
Okay, cool. All right. So did you want to, you had one more slide in there, what's next slide?
Oh, yeah.
Yep. Or you want to leave that for them to read on their own?
Yeah, this is it's more about since John reminded. So this is about the Longhorn roadmap, and I would say some moving part around, but basically next coming release is a Longhorn 1.3 in the Q1, and we try to enhance a bit, pay more attention on the API interface. Like I say, around the customer resource will be our de facto interface for users. If they want to operate a Longhorn in the headless mode, and because not everyone want to operate from the Longhorn UI, you want to have some automation integration, right? So this is the major thing we want to do. And also, like one question before is application backup restore, application consistent backup. This is also we are considering in 1.3. And the other one is a storage network, because right now the Longhorn and the database and control plane page is actually go through the same network state. So we try to think about it's possible to have the segregation for the control plane and data plane. So this is one thing to want to introduce a storage network. And cloud provider enhancement. We want to make sure we can resolve the possible the challenge in the cloud provider like auto scheduling, to make sure we can work well with this kind of mechanism or other things we need to evaluate for all the public cloud environments. And because Longhorn is agnostic the solution, so it can be committed to one on the different the platform. And the final one is rewrite managed, getting mature. This is one thing we need to prove it to work, because right now we based on the NFS the server, but we need to ensure which way a better way from the architecture point of view to make the rewrite managed work better and achieve a mature point. So this is for 1.3. But in the future, 1.4 or even 2.0, we have more items, and probably we can discuss a little bit in our meetup. So I encourage you guys join our monthly meetup, and we will arrange, we will change some way for running the monthly meetup, and have a more demo there to that you guys more understand Longhorn. Okay, great.
Awesome. Okay. So, well, went the wrong way. All right, we went through a bunch of questions. So I wanted to wrap up, and David, thank you so much for chatting with us today.
My pleasure. Yeah.
Awesome.
Yeah. Thank you.
Yep. And so it was great to have you on today. We have a few upcoming events. Everybody knows we are at KubeCon this week. There's a whole bunch of stuff going on there. There is
Yeah.
a live stream on the Rancher YouTube page. So go take a look at that live stream. There's a ton of interviews. There's a bunch of recordings are up there already. There's a ton of interviews that are happening live every day this week. So go check that out. If you're at KubeCon, which I doubt you would be if you're listening to this, but if you do get a chance to stop by our booth, please do. Get some others to do the same thing. We do have some special things coming for our November meetup. I can't divulge what's happening there yet because we're under an embargo, but you'll hear more about it at the end of October for our November meetup. And also, there's a lot of things that are going on in the community. So community.susan.com/events, we've got Up and Running Rancher, which was going on during this session. We have, that happens every Wednesday throughout October. We have an introduction to Kubernetes that happens every Monday. So take a look at that. That's the same class every single day, or every single Monday, but go take a look at that if you haven't already. Some good stuff that Luke and Robert and Tim present in the introduction to Kubernetes. Cloud Native at Scale is going on right now still as well. We have several more master classes in October. And there's one final thing that's going to be happening in October. The very end of October, we have a special guest, Nigel Poulton, who's a great talent when it comes to training around Kubernetes. He's going to be available for an Ask Me Anything about getting started with Kubernetes. So go sign up for that. There's 2 sessions, one that's friendly for the EMEA time zones, one that's friendly for the US time zones. So take a look at that. You'll be able to ask him any question that you might have. We expect to get a pretty good turnout for that. So get your questions in and go register for that event in the community, community.susa.com/events. Well, that's it for today. David, thank you so much for staying up so late with us. We do appreciate all of your time and all that great information about Longhorn. And everybody else, thanks for attending as well. We'll get the recording available and the slides available to you as soon as we can. So stay tuned for that in an email inbox near you. Again, thanks for your time. Have a great day, everybody.
Yeah, thank you guys. Bye.